Okay, in the first example, we're just going to see one simple application of the Colebrook and White equation. So we have like a water flow through a pipe with a diameter of the 1.2 meters. Has been constructed from smooth concrete pipe in which K, with the height of the protrusion, is equal to 0.60 millimeters. Hydraulic gradient SF, which is a H, is the hydraulic head loss divided by the length. A specific length is like the 1 in 250. So imagine this 1 in 250 is like a very common practice for the hydraulic gradients. It means that every 250 meters length of the pipe, we have 1 meter drop of the head loss. Okay, just pay attention to this point. New dynamic viscosity is like the 1.005 times 10 to the minus 6 meter squared over a second. Calculate the mean velocity flow using the Colebrook-White equation. So, we have like a simple equation to calculate the V directly from the Colebrook and White. If you remember, you can have that formula in hand available. So imagine that let's see what do we have. K, we have K like the 0.60 millimeters. We need to, once before using the equation, we need to just substitute all like the values in metric or SI units. So millimeters needs to be converted to the meter. So it's like the divided by 1,000. So it's the first one, K is like a 0.00060 meters, and SF is like the 1 over 250. You can calculate easily this one. What is the value? 1 over 250. 1 over 250 is equal 0.004. I'm just going to write it here. And once we just have this equation, let's look at this equation. Velocity is like the question here. We're just going to need to calculate mean velocity of the flow. On the right-hand side, D is a diameter. So we have the diameter 1.2 meters. SF, we have that one in here. And inside the log, we have the K. K has been calculated. And the metric unit we have, D, we got the log, the D. Nu has already given to us dynamic viscosity, and the D and SF, all of the values we got. If you substitute all the figures here, finally, we're just going to have like the velocity like the 2.363 meters per second. Just pay attention to this calculation. The equation here has got like the negative value, okay? But once, if you're just going to do this calculation, please make sure you practice that properly, because to calculate these terms, there are two terms inside the log, and you need to just calculate those two terms separately and make sure you calculate those two terms properly. If you're just going to have like a tiny mistake, the result will be something different from the final results. And just pay attention to this point. Log of this value, it gives a negative value. That's the important points. And negative value times a negative value here that we have in here, so it gives us the positive value at the end, which is like the velocity that we have in here. This is the example one, is a simple application of the Colebrook and White equation.